Behind every great result, there is a hidden process most people never notice. Welcome to the channel. Today, we are diving deep into this fascinating world to see how it actually works.
Black holes are known for their destructive gravitational power, regions of space that act as the universe's most efficient vacuum cleaners, pulling in anything that wanders too close. But the scientific catch that makes them difficult to track is that they are entirely invisible. Because their gravity traps light itself, a black hole completely blends into the dark void of space unless it is actively consuming the matter of a nearby star. This creates a gap in our knowledge. We don't know the location of every single one, and that leaves open the possibility of a quiet, hidden neighbor drifting through our region of the galaxy. To understand our true level of risk, we have to look at the ones astronomers have actually found. We are going to start at Earth and zoom outward, mapping the distinct categories of black holes known to science. Plotting these specific coordinates is the only way to answer exactly how close our planet really is to the edge of an event horizon. Our journey begins with our closest known stop, Gaia BH1, located 1,560 light-years away in the constellation Ophiuchus. Gaia BH1 is a stellar mass black hole, which means it formed from a dying star and weighs roughly 10 times our Sun's mass. Pushing slightly further out, we find two of its siblings. First is the heavyweight, Gaia BH3, sitting 1,840 light-years away at an impressive 33 solar masses. Beyond that is Gaia BH2, located 3,800 light-years from Earth. These close neighbors are currently dormant. They aren't pulling in matter, which means they pose no gravitational danger to our solar system. To find a larger class of object, we have to zoom much further out, 26,000 light-years away, directly into the center of the Milky Way galaxy. Sitting there is Sagittarius A star. This is a supermassive black hole, carrying the mass of about 4 million suns. While Sagittarius A star is vastly larger than the Gaia black holes, its distance ensures its gravitational pull has no impact on our solar system. We are simply too far away to be drawn into its orbit. Now we leave the Milky Way entirely and travel 55 million light-years out to the center of the Messier 87 galaxy. Here we find M87 star, a supermassive black hole weighing as much as 6.5 billion suns. Because of its enormous size and the way it actively feeds on gas, M87 star was the perfect candidate for a milestone in 2019. It became the first black hole ever to be directly imaged by humanity. To capture that image, astronomers used a global network of observatories, effectively turning the entire planet into one giant telescope. This highlights a contrast in our map. The only black hole large and active enough for us to actually see is located tens of millions of light-years away from our neighborhood. Let's snap our perspective all the way back from 55 million light-years to our starting point, our close neighbor Gaia BH1, just 1,560 light-years away. To understand how far away that really is, we have to look at the raw math. A single light-year is roughly 9.46 trillion kilometers. When applied to Gaia BH1, the resulting distance describes a gap stretching for nearly 15 quadrillion kilometers. Even in our fastest current spacecraft, a journey to this nearby black hole would take tens of billions of years. Black holes are the most extreme objects in the known universe, but because the cosmos is so vast, those distances act as a physical barrier, keeping our solar system safely isolated.